Welcome to the video lecture series on testing of VLSI circuits. In this video lecture, we can see about the Boolean difference method for fault diagnosis purpose. Let us consider the stuck-at fault as an example and we can discuss about this. Coming on to the definition of Boolean difference method. If the given Boolean function is represented by f with respect to some variable x, output when x forced to 0, that is considered as first function. The second function is output when the given variable is forced to 1. Then both the functions are XORed, and using this we are going to identify whether the fault can be identified or not. So the principle behind this is, if the dou f by dou x, based on the definition, if it gives 1, then it indicates that output depends on the variable x. When it is 0, then it indicates that the output is independent of x. Fault and x cannot be observed at this condition. So this is the background of Boolean difference method. So this can be made clear by using a very simple example where A, B and C are inputs, F is the output. For the given example circuit, the step 1 is to find the Boolean function. So here we will get A dot B. Here this is OR gate, so we will get A dot B plus C. It's a very simple function. So after identifying F, which is nothing but AB plus C for this case, next step to apply the Boolean difference formula. So for this we have to consider two cases, x to be forced to 0 and x to be forced to 1. Here, as we are going to check the stuck-at fault at 0, we are planning to do that, right? So we have to do with respect to A. So dou f by dou A, because A is going to be the fault affected input. So at A is equal to 0, the function becomes 0 into B, that is 0. So the f becomes C. Next is we have to find at A is equal to 1, what is the function value? When you substitute A 1 into B, you get B plus C. So F1 is equal to B plus C. So we have got these two conditions. F at A is equal to 0 and F at A is equal to 1 for this scenario. Now we have to do XOR of these two. C exclusive or B plus C is nothing but BC bar. You can, since you are aware of A XOR B formula, A B bar plus A bar B, using the same basic XOR formula, you can find the exclusive OR of C and B plus C, and you will be getting the answer as BC bar. So this is the step 2. Step 3 is to determine the test condition. So when B is equal to 1 and C is equal to 0, from this, because this is having complement, right? C is having complement, so it should be 0. These conditions will sensitize the path from A to the output as per the basic Boolean difference method. So now, if you want to find the stuck-at fault at A, that is at stuck at 0, what you have to do is, to identify the fault, we have to set that as opposite value, A is equal to 1, because fault is 0. So the test vector becomes 1, 1, 0. So 1 into 1 plus 0 is going to be 1. If you substitute the value of 1, 1, 0. So for a good circuit, it should be 1. For example, if the stuck-at fault is going to be available, then surely A will be 0, 0 A plus 0 will be 0. So at faulty condition, surely we'll get to know that there is a fault. So the fault is detected. So can you understand how the formula, Boolean difference formula is used in identifying the fault? Let us go for examining the given function at all the 8 combinations. If you look into all the 8 combinations for good and faulty circuit, for the for test vector condition, you can identify the fault. Can you understand? If it is good, it should be 1. If it is bad, it is 0. So this forms a perfect test vector for the given scenario. Okay, so for the example considered, first you have to apply the Boolean difference formula. For example, if the stuck-at fault is at B, you have to find dou F by dou B. If the stuck-at fault is at C, you have to find dou F by dou C at 0 and at 1. Got it? So this is how you have to go for modification of Boolean difference formula based upon the existence of fault. Okay. Coming on to the advantages of Boolean difference method. Here, no explicit path sensitization is required. Mathematical and it is systematic approach suitable for ATPG algorithms. Previous video we saw about path sensitization where we have to go for identification of fault path, sensitize it, uh, um, identify the non-controlling values, substitute it, forward trace, back trace, all those things are there. But here it is just a systematic approach to find the test vector easily implemented using symbolic computation. So the disadvantage is it is good at combinational circuit, it is not suitable for sequential circuit and large circuit. Used in many applications that are shown here, like stuck at fault testing, automatic test pattern generation, fault diagnosis, testability analysis, DV, design verification, digital IC manufacturing test, etc. Okay, I hope you got a basic idea about the Boolean difference method. To summarize the method, first, we have to identify the Boolean expression function for a given circuit, then apply the Boolean difference formula based upon the appearance of input text fault condition and its value. We have to find dou f by dou x at 0 and at 1. For both the cases, we have to find and we have to do exclusive OR operation. Then we have to find the input conditions based upon the dou f by dou x, then excite the fault by assigning the opposite value, and then finally identify the test vector. So this Boolean difference method forms an important foundation for the modern automatic test pattern generation techniques used in VLSI testing. Thank you. Thank you for patient listening.